Imagine this. You walk outside one quiet evening expecting the usual calm glow of the moon. But instead, you see something that freezes your breath mid step. The moon looks bigger, not just a little huge glowing like a pale rising planet dominating half the sky. At first, you think it's an illusion, but then your phone begins vibrating with emergency alerts. Astronomers confirm the impossible. The moon is no longer drifting away from Earth, it's accelerating toward us. Within just hours, ocean tides start behaving strangely. Shorelines retreat, then surge back violently. Boats slam into harbor walls. Birds flee inland. The sky shifts color as the gravitational pull of the approaching moon distorts Earth's atmosphere. By midnight, the moon has grown even larger, so close that you can see craters with your naked eye. Buildings tremble. Power lines sway. Entire cities near coastlines are told to evacuate. Scientists scramble to explain a phenomenon that should have been physically impossible. Some think a massive asteroid altered the moon's orbit. Others fear something far worse, a mysterious force pulling the moon inward, faster and faster. And as the hours tick by, one horrifying truth becomes clear. If the moon keeps falling toward Earth, the tides won't just rise. The planet itself could break apart. You stand outside, staring up at the monstrous glowing disk in the sky. It feels like the end of the world has already begun. Before we dive into what would truly happen next, slip this video, subscribe to the channel, and comment your question below. For billions of years, the moon has been slowly drifting away from Earth, about 3.8 centimeters every year. That gentle separation stabilizes our tides, our seasons, and even the rotation of our planet. But in this hypothetical scenario, something unimaginable has happened. The moon has reversed course and is now moving toward us. This setup isn't just dramatic, it's scientifically fascinating. Because the Earth Moon relationship is a delicate gravitational dance. Change even one step, and everything else begins to collapse. So, in this video, we explore a question that scientists normally avoid because of how catastrophic the answers become. What if the moon started falling toward Earth? To understand this, we'll break down the physics of orbital decay, tidal forces, and gravitational stress. We'll see how a slightly closer moon changes ocean tides, weather patterns, volcanic activity, and even Earth's crust. The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes with ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. In fact, there is no top or bottom to the scale. But even if 10 isn't the top of the scale, it might as well be. A magnitude 9 earthquake already measurably alters the rotation of the Earth. The two magnitude 9 plus earthquakes this century both altered the length of the day by a tiny million. Magnitude 9 was likeliest for reliking our minds in what happens as the moon crosses critical distances like the Roche limit, where the moon itself begins to break apart? And finally, we'll imagine the long term consequences. Could humanity survive? Would Earth remain stable? Or would this event mark the end of the planet as we know it? This is not just a story of astronomy, it's a story of oceans, air, rock, and everything holding our world together. Prepare to explore one of the most extreme what ifs ever imagined. The first major consequence: the tides turn violent. As the moon moves closer, the very first consequence hits Earth with overwhelming force. The tides transform from gentle ocean rhythms into destructive planetary waves. Right now, the moon's gravity pulls Earth's oceans into two tidal bulges. These bulges cause our predictable high and low tides. But when the moon moves closer, even by a few thousand kilometers, this effect grows exponentially, not linearly. A small orbital shift results in massive increases in gravitational pull. Within days of the moon's inward movement, coastlines around the world experience super tides. Beaches vanish. Entire coastal districts flood twice a day. Storm drains pour backward. Rivers reverse direction during high tide, carrying salt water far inland. But as the moon continues to fall toward Earth, the tides don't just rise, they become catastrophic events. Massive tidal walls, similar to tsunamis but occurring every 12 hours, slam into continents. Ships are tossed like toys, ports are destroyed, millions of people near coastlines are forced to relocate permanently. And the oceans aren't the only things moving. The moon's amplified gravitational pull begins tugging directly on Earth's crust. This is not science fiction. This already happens today, just on a tiny scale. Tidal forces slightly deform the Earth by a few centimeters. But with the moon closer, Earth's crust bends by meters, not centimeters. This causes an immediate spike in earthquakes and tectonic stress. Fault lines locked for centuries suddenly break loose. Volcanic regions become hyperactive as magma chambers feel the gravitational pressure shifting beneath them. Even Earth's rotation begins to change. A closer moon slows the planet down, lengthening the day by minutes, then hours. The sky begins to shift in a way humans have never witnessed. And this is only the beginning. The true chaos starts when the moon gets even closer. The second resemblance, the Earth itself begins to break. As the moon continues spiraling closer, the situation shifts from dangerous to apocalyptic. At around 50,000 kilometers away, just 1/7 of its normal distance, the moon's gravitational pull becomes violently strong. You wouldn't need scientific instruments to notice. The evidence is everywhere.
Earth to strive has become biblical.
Massive supertides rise hundreds of meters high, flooding coastlines and swallowing cities. Every 6 hours, the oceans retreat and return with planet shaking force. The energy released is equivalent to thousands of nuclear bombs per day. Rivers reverse, lakes overflow. Entire countries begin moving inland. But the oceans aren't the only thing being ripped apart. Earth's crust starts to flex. The moon's gravity stretches the planet like taffy. Solid rock rises and falls by several meters. This creates worldwide mega earthquakes, lines of volcanoes erupting simultaneously, cracks in the crust that glow red with exposed magma. Regions, like the Ring of Fire, explode with activity. Dormant volcanoes, quiet for thousands of years, suddenly awaken. Ash clouds darken the sky. Lava rivers carve through forests and cities. Even the air feels different. As the moon drags Earth's atmosphere upward, storms become monstrous. Hurricanes merge into hyperstorms, swirling across entire continents. Lightning storms flicker nonstop, creating a world of endless thunder. Meanwhile, the moon itself isn't safe. The closer it gets, the more Earth starts pulling on it. Tidal stresses cause landslides and fractures across the lunar surface. Huge chunks fall off and burn through our atmosphere as fiery meteors. Every hour, the moon grows larger in the sky, an enormous cracked sphere, surrounded by a halo of debris. People can see dust clouds swirling on its surface with the naked eye. Scientists calculate the inevitable. If the moon keeps approaching, it will cross the Roche limit, the distance where it can no longer hold itself together. And when that moment arrives, the true catastrophe begins. As the moon spirals deeper into its death path, Earth enters a stage of long-term planetary transformation changes that humanity cannot simply adapt to. These are the final consequences of a lunar approach that never stops. First, Earth's rotation collapses into chaos. Before the moon began falling, it acted like a stabilizer, keeping Earth's axial tilt steady. Without that stabilizing force, and with gravitational stress pulling unevenly across the planet, Earth's tilt begins to wander wildly. Seasons become unpredictable. Summer heat waves strike in what should be winter. Blizzards hit regions that once stayed warm year-round. Climate zones dissolve. Second, the oceans permanently reshape the continents. Centuries of megatides erode coastlines faster than humans can rebuild. Entire countries shrink as water repeatedly floods inland and recedes. Over time, coastal civilizations vanish, forced to migrate hundreds of kilometers toward higher ground. And with the moon's fragments now forming a dense ring around the planet, sunlight hitting Earth becomes uneven. Some regions enter long-term dimming as ring shadows sweep across them. Others experience bright, almost blinding refraction as sunlight scatters through lunar debris. Agriculture struggles, food supply collapses. Volcanic activity continues increasing for decades. Weak points in Earth's crust, already stretched from the moon's gravity, erupt constantly. Ash clouds cool global temperatures. For long periods, Earth experiences volcanic winters, followed by sudden rebounds of extreme heat when the atmosphere clears. One surprising long-term result emerges. Earth becomes tidally locked to the ring system, rotating in sync with the gravitational mass of the debris. This creates a strange new world where the ring appears fixed in the sky above certain regions, glowing at night like a silver halo. Human civilization, if it survives, will be forced into isolated pockets of habitable land. Massive engineering domes, artificial agriculture, and underground shelters become the norm. The planet never returns to its former stability. Earth becomes a hybrid world, part natural, part engineered, permanently shaped by the shattered remains of its own moon. In the end, the moon doesn't destroy Earth directly. But the world it leaves behind is almost unrecognizable. The moon was never just a glowing rock in our night sky, it was a stabilizer, a guardian, a silent architect shaping tides, climates, and even the rhythm of life itself. But in this hypothetical scenario, as the moon moved toward Earth, each step of its descent unleashed a new wave of destruction, first subtle, then violent, and finally planet shattering. The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes with ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. In fact, there is no top or bottom to the scale. We saw earthquakes and volcanic eruptions intensify as Earth's crust bent under impossible gravitational stress. Cities fell, weather systems collapsed, the planet spiraled into chaos. And then came the final threshold, the Roche limit, where the moon could no longer hold itself together. It tore apart, forming a glowing ring around Earth. But that wasn't salvation. The debris rained down like celestial fire, heating the atmosphere, darkening the sky, and transforming Earth into a world choked by dust and molten fragments. In the end, humanity's survival would be unlikely. Earth, once blue and full of life, would become a scarred, unstable planet orbiting under a shimmering ring made from what used to be its only natural satellite. This scenario reminds us of something profound. The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes with ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. The Richter scale, which has technically been replaced by the moment magnitude scale, measures the strength of an earthquake. Since we usually hear about earthquakes with ratings somewhere between 3 and 9, a lot of people probably think of 10 as the top of the scale and 0 as the bottom. In fact, there is no top or bottom to the scale. But even if 10 isn't the top of the scale, it might as well be. A magnitude 9 earthquake already measurably alters the rotation of the Earth. The two magnitude 9 plus earthquakes this century both altered the length of the day by a tiny. The moon saved us. The moon shaped us. And without it, everything we know would unravel.